I lost my voice last week, so I'm a little bit still. I don't quite sound like myself right now. But anyway, welcome. Thank you for coming. So I'm talking about mixed reality simulation, and I guess sort of more the robotics context of that, and sort of the high-level overview as to why we might want to do something like this and how Ruby ties into it. First of all, how many of you here are robotics people? Anyone do any robotics? Cool. All right. A couple of people. Sounds good. And then anyone know about DragonRuby or have played with it? Okay. So cool. There's a good assortment there. Okay. So I'm Kota Weaver. I'm a founder of a robotics company out of Boston called Skylar Technologies. We basically try to build robots that basically are human aware, so they navigate without running into people and without slowing down much and things like that. And also we do robot arm manipulation and things like that. So this is a robot that we have out on the market that we collaborated with DMG Mori, which is a machine tools company. And, you know, we build software for robots like that. I primarily work with C++ and Python, so admittedly Ruby's not actually my my bread and butter. Our stack also has a lot of Elixir and Rust. So simulators. Most of our work is in simulators, right? So we start off by building a model, putting it in a simulation. So this is Gazebo here, which is used all over the place. It's the standard one for ROS, and NASA uses it for their robots as well. And so this right here is an omnidirectional wheel, omni wheel, and so we actually have each of the barrels simulated as well. And simulators are a lot of fun to play with. So this is basically 4 omni wheels on a vehicle that's kind of rolling down a hill, and you know, you can see that I think the video should show all of the individual barrels and things like that rotating. So you can actually see, you can do pretty comprehensive simulations just on pretty, standard hardware. Now, there is this one problem where when we look at this, and there's a robot here, we actually don't really know how fast it's driving or how big the robots are when you just look at them, right? So that's actually a pretty common problem where you start building a lot of things in simulation and spend too much time there. And if you don't really have that feedback loop with a real robot, you kind of lose sense of reality. So that's actually a really key point where, so this robot was driving about 0.5 meters a second, which, is actually pretty slow, but it's really hard to tell just from that. So that's a standard issue that we end up running into pretty often, especially when we try to present things to customers. In addition, when you actually have these robots in various environments, that impacts as well, because in a very large space, robot looks much slower than it might actually be moving. So all of that really plays a big part of the kinds of work that we end up doing. So sometimes simulations also do some kind of funky things. So you'll notice that this one here kind of flipped over. Not actually sure why that did that, but they're very often pretty finicky in terms of the parameters, and depending on the integrators and things like that, you end up running into issues like that. Here's another case where it's very unstable, and don't worry, that's not the robot that we sent to customers. They do drive a little bit better than that, but these are typical issues that we run into. So we began looking into better options for simulators, and what we wanted were things that were not easy to destabilize. We didn't really need anything that was very complex, right? Because in vast majority of our cases, we're dealing with vehicular, basically 2D simulations, because these are just on planes. And then for like robot arms and things like that, that's not necessarily something we need to handle in this case. Headless is important so that we can do things in CI. fast startup. This is one of those things where the harder it is to actually boot something up, where the longer things take, the slower the development cycle. So that ends up impacting us quite a bit. And again, 2D is fine by me. And another key thing is it's easy to describe various scenarios and environments. And we couldn't really find anything for our needs here. So I didn't really find anything yet. So we're working on something for that. But that's something which is a typical problem that we run into, and a lot of people in robotics do as well. So I ran into DragonRuby while looking for a simple game engine to start building a simulator that better fit my needs. So DragonRuby is a pure code game engine, so there's no unnecessary UI. I don't know how many of you have worked with other game engines, but very often there's like these really complicated UIs that just, make it a lot harder to just get started. As someone who primarily builds robots, I want to keep that learning curve as low as possible because I don't spend that much time doing that. So that's the second piece. It's very easy to get up and running, which means the other members of my team who, spend all their time in Elixir or in Python or in C++, they don't have any problems getting started with this either. The API also is very, very small, and it's used to make real video games, which Amir, who's sitting over there, who's the founder of DragonRuby, used to develop games for mobile and for various console platforms as well. So I did promise you that it's pretty easy, so I figured I would do a little bit of live coding. How is everyone's high school physics? Okay? All right, good. Okay. We'll see if mine is okay too. But let me see. Okay, so I'm just going to bring up some code. Okay, so the very first thing I'll do is, right now I am in, none of you can see that. Okay, so right now I'm in just the DragonRuby's root directory. So in order to create a new project, and Amir is not gonna like that I'm not using his method, but I'm just gonna create a new directory, and I'll just call it Springs, I guess. And we'll just add a folder called app, which, here we go. And in here, I'm just creating a file called main.rb. So this is just the main file that we'll be working out of here. Okay, so now inside of this, okay, you can see that good. We can create the main loop. This is the main event loop. And now, if we go into the terminal, and where am I? Let's see, Springs, and Springs. There we go. Okay, so then if I go up one and call DragonRuby on this directory, you will see that we now have our DragonRuby window. So one of the cool things about DragonRuby is that we can actually just start typing away, and whenever we save it, hot loads. So if we, for example, create a rectangle or square, I'll just put this in the middle of the screen. 20 over 2, and we'll just have this have a width and height of 40, and I hit save, and now we have a box in the middle of our screen. It's very, very easy. Now we also actually want to move this thing, so maybe the first thing we'll do is we'll use a variable instead. So in DragonRuby we use a state, which basically helps us serialize and deserialize things, so we can save and load data much more easily. And so this is kind of where we store a global state as well. Okay, so then we'll just use an initial value of, just put it in the center, and if args.state.tick count. So basically, when we start up, we want to call this, and we can also have it reset upon saving with the thing on the top. Then, we also are going to do our initial velocity. So of course, and then we can take our x from there. So now if I go ahead and change this to a different value, for example, 100, it'll shift to the left, right? And so, let's see. Yep. Okay, so now we want to have this move as a spring, right? So the basic equations that we need for this are F equals negative K times X, which is the spring equation. So K is the spring constant, X is the displacement of the spring, right? So this is a pretty simple function, equation. And so we'll just use, and I'm cheating a little bit here because I know I tested this out earlier, values that work. So for dx, I'm going to use the center of the screen here. So that's 1280 over 2. And then we're looking at the displacement. So our rx.state.x minus that is our dx here. And then, because DragonRuby works at a fixed tick time rate, so it's 60 frames a second, we could have a dt in here, but we can also just assume that it's tied into the parameters. So the next one that we do is F equals ma, which of course, the famous one, right? So we can just assume a mass of 10 units. And then for this, v equals a times t, it's the velocity. And in this case, because we're assuming it's some constant, we're not dealing with real world units right now. And so therefore, all we need to do is add, let's see, vx plus equals, do I call it v or vx? Yep, okay. So this is basically where every time we're adding to our current velocity, the acceleration. And then finally, we can get our velocity by integrating we can get our position by integrating the velocity. So it's just, yep. Guess I can hide that. Yep, okay, cool. rx.state.x plus equals, and then the current velocity, and I believe if I save now, we should get no movement because it's still in the center. But if we instead move this, so recall that just by doing something like this, we can shift it to the left, and then, did something wrong here, I guess. Reset. That's what I did wrong. Okay. Dot x equals 100, and then it should shift to the left. Shouldn't move, but it's moving. Okay, well, point being, it's supposed to do something like, okay, that one's broken too, I guess. Anyway, point being, with just a few lines of code, you can actually start creating simulations in a very kind of intuitive way. So DragonRuby, basically, this was the enabling technology for a lot of the kinds of things that we're looking for. So I very quickly got addicted. And on the first day of DragonRuby, this is what I made. So it's a little, system to create various shapes, I guess. It's almost like a, vector editing tool. You can save and load images and things like that. Second day was this little physics simulation, little soft body kind of thing. So you have, these spring-like systems and various like cloth-like things. And the next week, I was doing some 3D stuff. Note that this is a 2D engine. And then the next day I was doing, I know some of you were here for the drone talk earlier. This is 2D on, or 2D game engine drone game, I guess, of sorts. And then, within a month of using DragonRuby, I was doing things like this, which is like a little 3D modeling tool using DragonRuby. Now, the main point of all this is that DragonRuby is incredibly fun, very, very quick, simple, and it solves a lot of the problems that I was trying to solve in my robotics problems, right? So the next thing, projectors. So the issue that we're running into with simulations, largely of just not knowing what the right scale is, things like that. You naturally go towards using real robots as well, right? That's a very important part of the development cycle. And so when we run the real robot, well, there's some problems there where it's still difficult to actually visualize what you're doing. And in your physical space, there's a pretty limited number of options as to what you can do. Our office is, we have about a 3,000 square foot space for robot testing, which maybe is about, about a third of this room probably in total, or yeah, maybe a little bit more than that. But it's not a huge amount of space. And as a little startup, that's the kind of issue that we run into. And even when working with big companies, they usually don't let us just drive everywhere. It's usually a pretty localized space. But at customer sites, we actually very often deal with having to drive 200 or 300 meters, sometimes even a kilometer from one side to the other of the factory. And in addition, the configuration is always very different, right? So, what we do with the real robots, we tune the parameters, we get a better sense for the real motion, and we deal with situations that also aren't hard to simulate, which is very often human behaviors and various sensor information. So there's actually kind of issues on both sides here. So in order to solve that, I bought projectors. I bought probably about 15 projectors, and I tried to put them on the ceiling. So this was my first try. Didn't really go so well. A couple other angles of that same attempt. Turns out if you try to put a piece of wood that's bigger than the opening in the ceiling, it's not going to fit. But eventually, after some maneuvering, I managed to get it. Had to take it apart, assemble it in the ceiling as well. So that was a little bit tricky. But the point being here, what we were doing is lining the ceiling with these projectors. And what that lets us do is it allows us to merge. You probably can't read that in the back. So essentially what we're doing is we're taking data from the robot, sensor data from the robot, and we're putting it into a little simple simulation. And we merge the LiDAR data or the sensor data and send it back to the robot, and the robot then operates on that. Then from there, we also send that data to the projectors, and we send it to the host who might be manipulating the simulation in some way. So this is actually, it's comprised of a few different languages, a few different systems. So the robot, primarily Elixir, C++, Python, and there's some Rust. And we actually do use Ruby and Slim for basically describing the configuration of the robot. And then we send that to the simulation, which is in Ruby. And then from there, we actually use ZMQ to pass this data to DragonRuby, in part because DragonRuby doesn't natively have TCP support yet. So there's this nice C extension feature where you can write additional parts in C. So I added in some ZMQ support for that, and then we tied in all the components that way. And so this is sort of view of setting everything up. So you can see that's actually the black boxes there. That was about probably about 3 minutes of or 5 lines of DragonRuby code to get that to visualize. So really kind of the big thing here is that DragonRuby has really helped us speed up this process, because even if I was to go ahead and grab an image from the internet of a grid and plop it on there, it takes a lot more time. It takes time to calibrate these things, make sure everything's in the right dimensions. So for us, this has been a really easy solution. And because of the hot loading, I can also actually just directly do that on the projectors themselves. So if I need something very quickly, I just SSH into that, and then whenever I save, it automatically reloads what's showing on the projector. So there's also this client here, which this is what we actually use to manipulate the environment. So we can zoom in, we can rotate, we can move things around. This blue section here, that's a dynamic obstacle, so to speak. So basically it moves between the 2 points, and then the green is the location of the robot. And this client is actually the exact same thing that we use to project down onto the floor as well. So kind of the big point here is, so it's all written in DragonRuby. You can manipulate everything, and also everything. Oh, important point, all this actually runs directly on Raspberry Pis as well, so you can keep things very low cost. So kind of putting it all together, you end up with something kind of like this, where we have a robot. You can see that I need probably brighter projectors, and that we actually have things pretty well calibrated here. This is actually feedback from the simulator to the robot, so you could see the robot slowed down a little bit when it went towards the blue box, so it waited for the obstacle to pass by. So that's basically the kinds of things that we've been working on with Ruby and simulation. As far as kind of the future plans that we have, there's a lot of sensor data that I want to visualize. Some of that I'm not sure DragonRuby's quite fast enough for yet, but maybe I need to finagle that a little bit and get it to go to be more performant, I guess, on my own code. And then I also want to add more projectors, so this thing tends to scale pretty well. So instead of the 6 that we have mounted right now, I want to scale it up so that the entire space is covered. And also we do have hardware in the loop simulation for robots as well. So figure that's kind of the next thing to tie in. We can have multiple robots in this sort of mixed reality space where we have virtual robots interacting with real robots. And I was hoping to actually get that done for today, but sometimes it doesn't work quite that way. Anyway, I think that wraps up what I had to talk about. So I don't know if there are any questions. Thank you.
Sorry, the question was, so as far as the visualization, you're able to get that running inside of the projector?
No. I have a
you have a
Raspberry Pi connected to the projector.
Gotcha.
Yep, up in the ceiling.
Okay. That makes sense for certain definitions of sense.
Yeah, I think you probably are aware that DragonRuby probably does not run on projector hardware yet. So
Yet.
Yeah.
How do you handle the dynamic obstacle stuff? So you don't actually have obstacles in the room. It was just an area. How?
Yep. Yeah, so essentially vast majority of this kind of data that we deal with, basically, we have cameras, we have LiDAR sensors. So for the LiDAR, basically that's just 2D ray. It's just a ray, 1D ray, and they rotate this around very quickly. So we get these very fast scans. We get, I think, 40 scans a second, or 40 of these full scans a second, and each of those consists of 1080 scans. So you get, this very responsive thing. And so we actually send that data up, and then we do basically a min on that versus what the simulated robot would be seeing. So we basically project from that what it would look at. So it's, and then we send that result back to the robot. As far as like camera data, that becomes a lot trickier. I think one of the approaches that we've also taken here is a lot of this stuff just basically gets turned into a higher level, a more abstract characterization through the form of a cost map. So this is basically like an image of what's occupied and what's not, what's dangerous and what's not. So we also do convert to that kind of thing and send it back there. And then, yeah. Okay. Anything else? Pi 3's doesn't really work that well. Yeah, you have to go with the Pi 4. Yeah. It's actually pretty surprising just how big a gap there is between the two when it comes to running this stuff. So, yeah. And then actually, admittedly, more recently, we've purchased IPCs basically to replace them, something a little bit more powerful. Yeah. Yep. So I think the question was basically to do the rendering on the Raspberry Pi or on like whatever server it is, and basically just send out the result to other machines, right? So I thought about that. Part of that is just I think there's a scalability issue when it comes to that. So when we're talking about having 10 projectors or whatever it is, that becomes a lot more difficult. So that's part of why we didn't do that. Yep. Go ahead. Right. Yeah. So, now you're talking about like real robotics questions, right? So, what we typically do, I think the most popular ways are using what's called a Kalman, or Monte Carlo based like localization. So, particle filters, various filtering techniques where essentially you have a map, a preset map, and the robot looks at its sensors and does some sort of calculation where it says, oh, what's the most likely place for me to be? And basically continually updates. So if you're interested, like Bayesian filtering techniques and things like that are the thing to look at. There's a lot there. Yep. Yeah, so there are a lot of different localization technologies. Ultimately, it usually helps to combine them in various ways. So if you can merge them, yeah, that usually helps. You don't want to invest in a $300,000 robot? Okay. Yeah, I mean, there are a few things on SparkFun that are, usable. The problem with these things is that a lot of these hobby grade things just either aren't powerful enough to be able to even run a lot of the kinds of things that you'd want to, but that's something that we can definitely talk offline about if you're interested in, like assembling some sort of kit for that, but go ahead. So we used to do all our own hardware. Then we realized that we're too small a company to be able to do that, and there's a lot of there's basically a lot of maintenance related things that we don't want to do. So we basically partner with with larger companies and provide the software for that. Okay. Yes, I think that's it, right? Yep. Okay. So thank you very much. Okay.